right, good afternoon, guys. So before we get into the study guide session, I just wanted to start by kind of describing the exam itself. So it's going to be 50 questions. All of them will be multiple choice. It's going to be taken on Canvas, similar to the other quizzes we've taken up to this point. You will have 48 hours to do it. So here's my plan. So I always record these meetings. So I am currently recording this one. And once I post it onto Canvas, I will also publish the exam at that point. So I have meetings today starting at 2, and they end at about 3:30. So if the meeting isn't done like record or uploading and then or downloading, then I got to upload it to YouTube and then back over to Canvas. If that part takes longer, then it will, excuse me, if that gets if that is not complete before my meetings at 2, then expect the exam and this video to go up around like 4 o'clock ish. I'll also post an announcement saying, hey, the exam is live. And then in that announcement, I'll also say you have until October 8th, which is 2 days from now at whatever time. So if I posted at 4, if the exam is published at 4, you guys can see it at 4. I'll say, all right, it's available on the 8th until the 8th at 4. So simple as that. It is open note. So if you would like to use notes, do so. That's fine with me. You have one attempt. So that one attempt is an hour and 50 minutes. So you have 48 hours to do the exam, but make sure when you start the exam, you are prepared to sit for about 2 hours to complete it. It might not take you that long, but if it's, I don't want you guys to start the exam at like 3 o'clock when it shuts down at 4 on Sunday and you don't have enough time to finish. So make sure that you allot enough time, at least 2 hours, to get that done when you do your attempt. Yeah, that's the exam. So again, I'll post an announcement, pretty much long story short, I'll post an announcement once this video and the exam itself is live. I would, of course, encourage you guys to watch this video first if you're not already here. That way you'll have an idea of kind of what to expect and our study session. So, Fiona, do you have any questions? Are there any points on the study guide that you want me to go over? Oh, okay. Well, if you don't really have anything in particular, my plan for this study session was I'm not going to go over each point in the study guide. Rather, I was going to go based on the questions that you guys had. Were there any points that you maybe wanted a little more explanation on? Because if not, I mean, that's okay, but because you showed up. But if not, the meeting can be over. Which two videos in particular are you talking about when you say going over some of the general information for the video? Ah, gotcha. Okay. So for the characteristics of the sample mean, keep in mind that this is relating to how we go from a sample like, oh, our class of 40 students to the population of, all Psych 42 students or all Fresno State students or all college students in California, whatever our population is, our samples are used to generalize information to it. The way we do that is by the sampling distribution of the means. So when I say, oh, characteristics of the sample mean, that is kind of related to how the sample is tied to the population mean, how we go from a sample and are able to say, able to conclude information regarding the population. This is done through, again, the sampling distribution of the means. I like to think of it like, imagine the population is a cake or like a recipe that we saw somewhere and it's like, ooh, that looks really good. I want to make that cake. It looks really good. That's our population. That's what we're interested in. This is what we want to know about. And then we have our sample of 40 students, 30 people, whatever our statistical sample is. But with this cake example, our sample would be something like our ingredients, our eggs, flour, sugar, cocoa powder, I don't know, whatever it is that goes into that cake. Well, to go from a sample to a population in statistics, we need a kind of filter. We need something that gets us from a sample to be able to generalize to the population. Just as when we're trying to make a cake, we need something to get us from flour, sugar, eggs, etc., to an actual cake that would taste a lot better. So in the cake example, it's an oven. We mix up our stuff. We have our cake batter poured in whatever mold, cake pan we want to use. We put it in the oven and then we let it do that. Then we work its magic. With statistics, that's that go between to go from the sample to the population is the sampling distribution of the means. Now, the first point, with it being an unbiased estimator, well, first, let's kind of look at what the sampling distribution of the means is. And let's go with our example of, let's say, all Psych 42 students. So we have all Psych 42 students, the ones at Fresno State, maybe at like city colleges, community colleges, across the country, I don't know, whatever Psych 42, we're all those students, however, how many hundreds of thousands of them there are in the population total, that's who we're interested in. Our sampling distribution of the means is going to have every single possible combination of 40 students. I think there's 40 students in our class, so I'll go with that particular sample size. So we are looking at every combination of 40 people, 40 students in our population of all Psych 42 students. So this is where that theoretical sampling method comes in, where in order for us to know, hey, how many samples are there in the sampling distribution of the means? Well, we would take our population size, again, however many Psych 42 students there are in, hell, let's just say in California, because the country is pretty big, but we're still going to get a lot in California. But all right, our population is all Psych 42 students in California. How many of those are there? I don't know. I'm just going to wing it and say 500,000, probably more, but I don't know. Let's just say that's our population size. And we are using a sample size of 40. So when I asked, oh, how many samples are in this sampling distribution of the means when the population it represents is all stat students in California and our sample size of 40, well, we take the population size, again, I estimated like 500,000 to the power of the sample size. So 500,000 to the 40th power. That is so many samples. I can't even begin to to imagine 500,000 multiplying by itself 40 times, 500,000 times 500,000 times 500,000, doing that 40 times, like that's a boatload. So it's important to note that this is referring to how many samples are in the sampling distribution of the means. This is theoretical in the sense that we are probably never ever going to see this distribution in real life. We already know it's hard enough to find like everyone in the population. It's already hard enough to get access to everyone in the population, but to on top of that find all the combinations of 40 in that population and graph it on this distribution. It's theoretical, but again, it's the oven that we use to go from sample to population. So when we say that the sample means are an unbiased estimator of the population mean, what that means is that for each individual point in the sampling distribution of the means, so we have our distribution. Let's say we're looking at exam scores. So we have the middle, the mean, maybe it's about like 70-ish. Let's say it's 70. And we have a point. Each individual point in this distribution is not an individual person. If there's a point on 70 in the sampling distribution of the means, that's not, oh, one person scored a 70 on the exam. That is an average of 40 people scored 70. So the average of this particular group of 40 was 70. And the average of this particular group of 40 was 62. The average of this particular group of 40 is 95, whatever. But each point in the sampling distribution of the means is not an individual person. It is the average of 40 people. So with it being an unbiased estimator, though, that's saying that if we took all of the means of the 500,000 to the 40th power samples, so a boatload of means, obviously, but if we took the sample means of each of those billions of samples, if we were to average all of them together, it would be equal to the true population mean. Whatever the actual exam one average for Psych 42 students in California is, that would be equal to finding the means of all the sample means. So we say it's an unbiased estimator because, hey, on average, again, when they say on average, it's saying if we take them all together and average them, but on average, the sample mean equals the population mean. So next we have the central limit theorem. And this is another way that we can, again, go from the population or from the sample to generalizing it to the population. We've talked about z-scores a lot at this point. You know, we've calculated them. We know they use the standard normal distribution, aka you know, the normal distribution has an area of 1. The mean, median, and mode are all in the center. It follows the empirical rule where 1 standard deviation above and below the mean is 68% of, 68% of the data. 2 standard deviations above and below the mean is 95%, and 3 standard deviations above and below the mean is 99.7% of the data. Again, z-table or the standard normal distribution, aka the z distribution, is a normal distribution. It has all of these characteristics. So does the sampling distribution of the means. That is, again, the distribution that has every single possible combination of a particular sample size within a population. So no matter what the population distribution looks like, so instead of each individual point being an average of 40 people, the population distribution itself, while there will be 500,000 points on it, one for each member of our population of Psych 42 students in California, again, one person in the population distribution represents exactly that, one person. But if that distribution of the population were to be not normal, if it were to be skewed, maybe having it, instead of kind of shaping it like a standard bell curve, like the normal distribution looks like, kind of like that camel's hump that we're pretty used to seeing, our population can be skewed, meaning it's like, oh, no one, no one, no one. Oh, and then all the data is kind of tilted to one side, to the lower end or the higher end of the distribution. That's known as a skewed distribution. Even if our population looks like that, when we take the sampling distribution of the means from that population, it will be normal every single time, no matter how janky, how wonky the population looks. If we were to have access to it, the sampling distribution of the means will always be normally distributed. And it's through this normal distribution that we can use inferential statistics. I know this is kind of a throwback way back when, but inferential statistics, after this first exam, we're going to be doing a new inferential statistical test each week. So the sampling distribution of the means, with it being normal, following the central limit theorem to where no matter what the population looks like, this will be normal. That's key. We need that for inferential statistics, because that is going to be a big part of, again, how we go from our sample of eggs, flour, and sugar to our population of the cake that we actually want to see. That's our oven. We need to turn it on and get it working so we can get our cake. Let me see. Oh, and then lastly, the third characteristic of the sample means is to have minimum variance. All minimum variance is referring to is just, a variance is a measure of variability. Variability is essentially, you know, how far spread is our data? Are all the scores the same? Which would imply, well, which would mean that there is no variability, or do the scores vary greatly? You know, do we have some scores super high, like 10,000, 5 million, and then super low, -50, -1 billion? I don't know. Do we have, like, it's the data, if we were to graph it, really fairly close to the mean? Again, smaller variability means the data isn't spread out so far. We don't have all these -50s, +100s, -5,000, +10,000. We don't have such a wide, like, oh, going back and forth, and like, we got data way over on that side and we got data way over on that side. Our variability is huge. Instead, you know, variability, the smaller it is, the less varied the data is, the less spread out, the less dispersed the data is. So to say that the sample means have minimum variance is saying, hey, you know how we have 500,000 people in our population of California? Yeah. Or, well, in our Psych 42 California population. Yeah, we have 500,000. Okay, and you know how we're taking every single possible combination of 40 within that massive group? Yeah, that's like a bazillion samples there. What about it? Minimum variance is saying, I bet you they're not all going to be the same. There's got to be someone in the population that scored different. Even if it's just one person, we can have a variability of, like, a measure of variance, let's say, of like 0.01. There is a minimum variance there. Again, if it's anything greater than 0, even if it's that tiny decimal, that is still telling us something's different. Maybe most of our scores are the same: 5 5 5 5 5 5 5 5 5 5 5 5 5 5 5 5 5 5 5 5 6 5 5 5 5 5 5 5 5 5 5 5 5 5. So even that's, oh, made me dizzy. Even that small variance, though, of 0.01 or whatever it might be, it's telling us, hey, not everyone in this population has scored the exact same on the first exam. You know, not every Psych 42 student across California is going to score the same on their exam. So when you think of it like that, it makes sense. Hell, even in our sample, if we were to use our class as a sample to represent the population of Psych 42 students in California, I mean, it's hard enough to get 40 people to score the exact same on an exam, let alone 500,000 people. So when we take all of the sample means, all those combinations of 40, well, the people within the 40 are students, Psych 42 students in California. So we might not even get any doubles within that sample of 40. Everyone might score something different. Minimum variance just means that you're bound to have some difference. There's bound to be some dispersion in your data set when you're taking the sampling distribution of the means, every combination of a particular size in a population. Okay. I know I covered a lot of different points with that, but I know that the characteristics of the sample mean is kind of a doozy. So I tried to do my best to kind of break it down as simply as I can. Keep in mind, it is more our theoretical usage of statistics. So it can be kind of more challenging to grasp, and I understand that. But yeah, that's my little slightly elongated, kind of brief, sure, explanation of that. So what other questions do we have? You're very welcome. Do we have any other questions on any of the points on the study guide? Okay. So theoretical versus experimental sampling. Now I already mentioned theoretical sampling, but I'll bring it up again. So this is these type of sampling methods allow us to know how many possible samples there are based on a population size and a sample size. When given the same numbers, when we have like the same population size and the same sample size, theoretical sampling methods will always, every single time, give us a larger number. Given the same population and sample size, it'll always be larger than its experimental counterpart. Why is this? Two parts. First off, the theoretical sampling method, there are two questions we have to ask. Does the order that the sample is selected matter? And are people being replaced? Or is there sampling with replacement there? So with theoretical sampling, the order does matter, and people are being replaced in order to be picked for the next member of the sample. And I'll kind of elaborate on that. So I like to use the classic example of picking teams for dodgeball. You know, when you're a kid and playing like or basketball or whatever sport you played as a kid, you know, typically how it is you get two captains for, you know, the two teams that are going to go against each other. You get your group of kids and the captains go back and forth choosing who's going to be on their team. Imagine that's your sample. Imagine our captains are picking samples. Now, the experimental method is better fit for picking dodgeball teams. The order doesn't matter. If I pick LeBron James to be on my basketball team, and then I pick Stephen Curry to be on my basketball team, I will still have the same players on my team. My sample will still be the same if I picked Steph Curry first instead of picking LeBron James first. That's experimental sampling methods. That is more, we use that more in actual practice as opposed to theory, the theoretical method. Also with experimental method, how it kind of channels this dodgeball / basketball team picking is the sampling without replacement. Experimental methods do not replace the sample, do not replace the participant selected for our sample back into the pool. So for example, imagine if I were to again be doing, I don't know any famous dodgeball players, so I'm going to go with basketball. But let's say, you know, I have my basketball team, or I'm trying to pick teams, and, you know, oh, okay, I pick LeBron James first. Okay, then it's the other captain's turn. Well, if we have sampling without replacement, I get to keep LeBron James. I picked him. He's on my team now. Now they pick the other captain picks someone else. Which is what experimental sampling methods use. Theoretical sampling methods use sampling with replacement. So, okay, I got LeBron James. Now it's the other captain's turn. Oh, but I'm going to put LeBron James back. So now he can be selected for that team. Sampling with replacement is when we're trying to decide, or when we're picking the members of the population to be in our sample, we can get doubles. There are samples in the sampling distribution of the means. Again, the massive, you know, 500,000 to the 40th power. There are samples in there that are just 40 times it's the same person. You know, Jimbo from Modesto, the average on his exam 40 times, because they're sampling with replacement for theoretical sampling methods. So if Jimbo got a 70, the average for his sample that consists of only him 40 times, that's going to be 70. And again, with theoretical sampling methods, the order matters. So there are tons of different combinations of just, you know, a basketball team of 5. Oh, I pick, you know, Michael Jordan, LeBron James, Kawhi Leonard, Klay Thompson and Steph Curry. Okay, I'm not going to remember all the players now because I was going to try and mix them up. But that's my team. That's my team of 5. But the order that I said my team for experimental methods, no matter how I mixed it up, no matter what position I put each of those players in, no matter what order I selected them to be on my team, it's still my team. Like that's still one team that I've created there. That's still one sample. But the theoretical sampling method is saying, so you have one sample, one team that you pick LeBron James first, then Steph Curry, then this, then that, then that. And a completely different team, a completely different sample would be picking Steph Curry first, then LeBron James, then all the same people. So there's always going to be more members, or there's always going to be more possible samples for theoretical based on this. So as far as the equations are concerned, I do remember them. But for me to write them makes no sense. Or for me to speak them, well, for theoretical, it's a little easier. For experimental, it's a little wonky. So for theoretical methods, For theoretical, we have our population size to the power of our sample size. It's pretty big. So again, let's say there's 500,000 people in our population, and we want a sample size of 40 for our sampling distribution of the means. Well, then we're going to take 500,000 to the 40th power. Experimental sampling uses factorials in its... now I can't see where the camera is. Okay. Experimental sampling uses factorials in its equation. So it's a little different. So again, how we calculate factorials is, let's say that we have a population size of 5 and a sample size of 2. I don't know. For theoretical methods, it's pretty easy. So again, it's over here. Population of 5, sample size of 2. Theoretical, we just have 5 to the 2nd power. That's going to give us 25. 25 total possible samples. Okay. But now for experimental sampling, to calculate it that way, well, a factorial is where if we were to count starting from 1 up to the number that we're trying to find the factorial for. So for the factorial of 5, we have 1, 2, 3, 4, 5. We multiply those numbers together. 5 times 4 times 3 times 2 times 1. It's kind of a doozy. So, all right. So I've done the factorial for 5 up here. So again, it's just the population size factorial divided by sample size factorial, population minus sample size factorial. So we got to do, I've done the denominator, or excuse me, the numerator first, just the straight population factorial up here, because it's not going to affect what's underneath it in the denominator. But I am doing this part step by step. So first, I just plugged in the information. So, okay, our sample size, oh wait, shoot, our sample size is 2, not 3, my apologies. My bad. I wrote a 3 there. I meant to put a 2, my apologies. So 2 factorial times whatever 5 minus 2, the difference between 5 minus 2 is going to be what we find the factorial for. So that's going to be 5 minus 2 is 3. So here, let me get the chat out of my way. Okay. So here, where is it? Okay, over here. So I just continue with the numerator of 5 times 4 times 3 times 2 times 1. That doesn't change yet. Divided by, okay, we know it's going to be the 2 factorial times the 3 factorial. So I started with 2 by saying 2 times 1. And now I get into the 3 factorial, which I calculated, of 3 times 2 times y. So, okay. I'm just going to pull out my handy dandy calculator real quick. So 5 times 4 times 3 times 2. I'm not going to bother multiplying by 1 because I'll write it down when I calculate it, but when I actually put in my calculator, I'm not going to do times 1. So 120 is my numerator of 5 times 4 times 3 times 2 times 1. Then let's see, 2 times 1 times 3 times 2 times 1 is 12. Yeah, 2 times 3 times 2. Yep. So now I have, what is it? Okay. I've done the numerator, that's equal to 120. The denominator, that's equal to 12. So now 120 divided by 12 equals 10. So I mentioned that given the same population and sample size, the theoretical number of samples will always be larger. And we see that happening right now. Both these methods we use to calculate how many total samples there would be, both of them had a population of 5 and a sample size of 2. Theoretical, we got 25. Experimental, we got 10. So as far as the exam itself, anytime with it being open note, you don't have to memorize the formulas. If you have the formulas in your notes, use them. I'm not a fan of making people memorize formulas. The only reason why I have them memorized is because I've been teaching the class long enough, going over these formulas. So I'm, teaching it every semester. But as far as practical usage, like if you were to, let's say, take a research methods class or use statistics in some way outside of this class, chances are you're probably not going to be doing it by hand. You're going to be using Excel at the very least, or a statistical software. So the formulas can come and go. Like there's a point deep enough in statistics where you're not really using the formulas anymore. You got so much data, you're using like data software tools to help you figure it out. But what's important is, what is it telling you? Or what tests do I need to use? So long story short, feel free to just print out all the formulas and have it right there next to you for any exam that I give you. But I will be asking more questions. I mean, you will be calculating some theoretical and experimental methods of sampling, just like this example was. So that's out there. But then in terms of the grand scheme of, okay, so what does it mean? That's also a question. That's also something that, okay, well, we know that the theoretical sampling method, that's used to find the total number of samples in the sampling distribution of the means. And the sampling distribution of the means is how we go from the sample to generalize to the population. That's the stuff I'm interested in more so. Formulas, you can just look up and have handy right there next to you. It's knowing how these things are used and why we use them that's more important, in my opinion. So, yeah. Oh, anywho, any other questions? It's funny, I just got an email right now it's just a spam email, but I, for some reason, thought that one of you guys texted me your answer or your question, which I was going to be really freaked out by, but it's an email. I'm okay. All right. Do we have any questions? Any other questions? Any more questions? So I did state in the beginning of the video when the exam will be available, but I'll briefly restate it again because I have a feeling this will probably be the conclusion to our video today. So, well, that's why you got to prepare. You got to know. You got to look over that study guide and come with the questions now. So the exam is 50 questions, all of which are multiple choice. They come from a test bank. That's something I forgot to state earlier. They come from a test bank, so no two students are going to have the same set of 50 questions. You might have some similar, but no one's going to have the same set of 50. You have it's open note. And as far as when I will post it, once this meeting finishes recording and I'm able to download it from Zoom and then upload it to YouTube and then put it back onto Canvas, that once I do that process, once I post this video onto Canvas for you all to see, that is also when I will publish the exam. I have meetings today at 2 that go from 2 to 3:15. So if the videos are recorded and good to go, or well, video is good to go before my meetings start at 2, it'll be up before 2. If not, it'll probably be closer to 4 o'clock that you will see the exam and this video. I'll also post an announcement so that way everyone knows, everyone got an announcement saying, hey, you have, the exam is live. I give you 48 hours from when I posted it. So let's say, yeah, today at 4 p.m., I post the announcement saying, okay, it's live. That announcement will also say, okay, you have until October 8th at 4 p.m., 48 hours from when I post it, to do the exam. You have one attempt. That one attempt is 1 hour and 50 minutes. So you have 48 hours to do it, but try not to wait till the last minute. Again, if let's say, it closes at 4 o'clock, don't start taking the exam at 3 o'clock on Sunday because you might not have time to finish it. I allot you guys 1 hour and 50 minutes. So be prepared to set aside at least that to take your exam. But yeah, that's that. You're welcome. Alrighty. Well, it doesn't seem like you guys have any other questions. Unless do we have any other questions before I officially conclude? Yes. Yes. So if you have accommodations or any sort of, well, yeah, if you require accommodations, I also set up Canvas to where the standard time is 1 hour 50 minutes. But if anyone needs, 1.5 times the amount of the exam, I do that on Canvas. Canvas will set up, you will have the amount of time you should have based on 1 hour 50-minute exam. So yeah, 150 is the baseline. 1 hour and 50 minutes. Alrighty. Well, with all of that being said, I wish you all the best of luck on the exam, and yeah, I'll see you next time. Bye. Thank you. You too.